Okay, so hi, my name is Cezar Andrici, and I will talk today about my work on gradual enforcement of IO trace properties. So in F-star, in the programming language F-star, we can verify input-output behavior of programs by with static verification, and we can enforce trace properties on traces of events. So we could verify a web server, but web servers usually are linked with plugins or libraries, which are developed by third parties, and usually they have unintended behavior because they have no specification, so we don't know what to expect. So we are interested, how can we offer guarantees about what safety properties hold on this whole program with web servers plus plugins plus libraries. So let's start with how we do static verification in F-star. So we use the IO effect, which allows us to annotate functions with pre and post conditions. And this pre and post condition will be enforced statically. And for example, here for primitive read, the precondition says that for the file descriptor given as an argument, it has to be open in the past, in the trace of events that happened until now. And the post condition says that during the execution of read, only one event happens, and that's just a read from the file descriptor given as an argument. And more than that, it says that the value returned is the same value as it was read from that file descriptor. So in theory, if the whole program will be statically verified, the trace could be ghost. And as I said, using this IO effect, we verify the web server that serves files, that delivers files using the HTTP protocol. So we proved in F-star that the web server has a trace property pi. But what about libraries and plugins? So how can we enforce the same pi on them? So the first thing to do was to mix static and dynamic enforcement of IO trace properties. But to do dynamic enforcement, we had to make the trace, to have the trace allocated unupdated at runtime. This is even for the web server, which is statically verified. And this may seem inefficient, but the IO effect is parametric in the underlying primitive actions. And this offers us great flexibility for now. And to be able to mix static and dynamic enforcement, we did two things. We extended our primitives in two ways. And the first way is to make the primitives accept an extra precondition and to have different primitives for each one. One that enforces both preconditions statically or dynamically, and one that enforces the default precondition statically and pi dynamically. So our result here was that we obtained interoperability between static and dynamic checking, but the primitives were still in the IO effect. So we expect the plugin and the library to be in the ML effect, which is still an effect in F-star, which means that the plugin and library will be written in F-star. But the ML effect does not have any specification. And ML represents a safe subset of computations that can be used in native ML or CAML. So it's similar as writing code in a different programming language, but it's just a subset of what you can do. And after that, we defined at the F-star level new transformation functions between these two effects. Export will let us convert a static precondition or precondition which will be enforced statically to be a runtime check, and import will actually enforce pi on ML by adding runtime checks before each IO operation. So because it's before and it prevents pi, it will be a safety property. And this looks, okay. So pi can be any bool function. and in the future, we plan to extend it to extract it directly from an LTL formula. But for now, pi can be any bool function defined over traces and on the next operation. So for example, this pi here says that if you try to open a file, then the file name should be different of password.txt. And if you try to read from a file descriptor, then that file descriptor has to be open in the past. So what happens is that the plugin will get some kind of monitor which will observe each IO operation and decide based on pi if it should allow or block that operation. So here, when you try to do open file password.txt, it will block it. So what we get is that we can verify the web server that respects pi, and we can have any plugin in the ML effect. But importing that plugin with pi will give us that the plugin respects pi, and the web server plus the plugin respects pi. So the whole program respects pi. And a nice thing is the plugin is the only one monitored. Even if the web server has to update the trace, the runtime checks will be only on the plugin. So what we obtained is, as I said earlier, interoperability between static and dynamic checking of IO trace properties, and interoperability between verified and unverified code. And we also try now to extend our verified web server with an ML plugin mechanism. And that was it. Thank you. Do you have any questions?
Yeah, thank you very much. Any questions from the audience? No?
Okay, I guess I can. I actually have a question. Right, so I think you mentioned that your web server serves files, and yeah, I guess I'm just wondering how complex the web server is.
Well, it answers only to get the GET request, and it will search that file on the disk and send it back. So I suppose it's not that complex, but just a proof of concept. And we prove about our web server, it does not crash. We prove that opens files only in read only. So the web server will not be able to write in any file. And also that each request, the request handler will interact only with the client is given as argument. It will not interact with multiple clients. I mean, the request handler will be called with one client, and it will only interact with that client.
Right, and all these properties are verified in HTML.
Yeah.
Right. Well, that sounds great. Thank you very much.
Thank you for the question.
I was wondering what is the size of your F-star proofs?
Can you repeat the question?
So how large is your F-star proof?
It's quite large. I think it's 4 times the code for the web server, right?
Mm.
But so for the web server, there are 4 times more proofs than lines of code. Mm-hmm. But for the interoperability part, I suppose it's, I mean, F-star can prove that everything works using the SMT. Mm-hmm. Like you can mix dynamic checking and static checking, and the fact that you can import from ML to IO, FSTAR can prove those without any help using Z3. Is this answering your question?
Yes. And then in that case, so if you use some other proof assistants like Coco and Agda, will the proof be harder in some sense?
I suppose, because you'll have to prove it manually.
Mm-hmm. Okay.
But
Yeah, thank you.
thank you.
Any more questions from the audience? We still have some time.
Could you say a little more about like next steps or scaling up these ideas to more full-featured servers and other kinds of applications?
Well, our interest is not really to verify a web server. Web server is just a good case study, which is can be complex. But our interest is in making much easier much easier to prove that verified code and unverified code can be put together and prove that those two together respect some property, right? So in the future, for now, this interoperability works only for input-output behavior, but we are thinking about adding also state as an effect and divergence, and maybe more after that. But for now, these two are the next to tackle.
Mm-hmm. Okay, thank you.
Thanks.
Okay. If there's no more question, then let's thank the speaker again. Thank you, Cezar.
Thank you.